Most Toyota hybrid owners are draining their high-voltage traction battery up to 3 times faster every single summer, and they have absolutely no idea it is happening. This is not a manufacturing defect, and you will never see a recall notice for it. It comes down to a single overlooked air conditioning setting that forces the electric compressor to work so relentlessly that your hybrid battery cycles to death. The gasoline engine fires up far more than it ever should, and your fuel economy plummets by double digits instantly. Real thermal data from laboratory testing on a Toyota Prius plug-in hybrid confirms this exact nightmare. Choosing the wrong ventilation mode increases air conditioning power consumption by over 6% of the total vehicle energy, and in extreme summer heat, that number climbs even higher. The worst part of this entire situation is that Toyota actually built a smarter, battery-saving system directly into your dashboard. But almost nobody uses it because the dealerships never explain that it exists. Let's uncover what they don't want you to use. In the workshop, I see the aftermath of this mistake constantly. A vehicle comes in with a prematurely degraded battery pack, and the owner is completely baffled because they followed the oil change schedule to the letter. They think they just got a bad apple. But here is what they don't tell you at the dealership. Your driving habits inside the cabin dictate the lifespan of that massive battery pack under your rear seat. The catastrophic setting causing all this hidden damage is the fresh air intake mode on your Toyota Hybrid's climate control system. That small button on your dashboard, the one with the icon showing an arrow entering the car from the outside, controls whether your air conditioning system pulls in scorching outside air or recirculates the already cooled air inside the cabin. Most drivers press it without a single thought. Some leave it on fresh air permanently because they believe it is healthier or more comfortable. But on a Toyota hybrid, fresh air mode is the single most energy-destructive climate setting you can possibly choose. It directly accelerates hybrid battery drain in a way that most owners never connect to their falling fuel economy numbers. Why does this matter more on a hybrid than on any conventional car? In a traditional gasoline vehicle, the air conditioning compressor is belt-driven, meaning it runs off the engine mechanically. The energy cost is hidden inside the overall engine load. You feel it as slightly sluggish acceleration, but the engine is already running anyway. On a Toyota hybrid, the air conditioning compressor is completely different. It is a high-voltage electric scroll compressor powered directly by the traction battery, the exact same nickel-metal hydride or lithium-ion pack that drives the electric motor and propels the vehicle. Every single watt that compressor consumes comes straight out of the battery responsible for moving your car. When you force that compressor to work harder than necessary, the battery drains at a breakneck pace. When the battery drains, the gasoline engine has to fire up sooner and run longer to recharge it, meaning more fuel burned, more engine wear, and a hybrid system that is constantly cycling instead of gliding efficiently the way Toyota engineers designed it. Now, let's look at what the peer-reviewed thermal data actually proves. A study conducted on a Toyota Prius plug-in hybrid electric vehicle tested different cabin air ventilation modes under controlled laboratory conditions, using the Supplemental Federal Test Procedure SC03 driving, which specifically simulates real-world city driving with the air conditioning active. The results were striking. When the air conditioning was set to fresh air mode, the compressor consumed approximately 34.5% of total vehicle power. When switched to recirculation mode, that number dropped to 28.4%. That is a 6.1% reduction in total power consumption just from changing one single setting on your dashboard. On a hybrid, that 6.1% is not an abstract figure. It translates directly into how fast the traction battery depletes, how often the gasoline engine must engage, and how many damaging charge-discharge cycles the battery pack endures over its lifetime. Imagine sitting at a red light on a 95-degree day. Your Toyota hybrid is in electric vehicle mode. The engine is completely silent, and the cabin is cooling. In recirculation mode, the air conditioning compressor works with air that is already at or near your target temperature, spinning slowly and drawing modest power. In fresh air mode, the system pulls in 95-degree air from outside, runs it across the evaporator core, and tries to cool it down to your set temperature from scratch over and over again. The compressor spins at maximum velocity, draws massive current from the high-voltage battery, and the battery state of charge drops off a cliff. Within minutes, the hybrid computer detects the falling charge level and fires the gasoline engine to compensate. That engine run was entirely avoidable. Multiply that by every stoplight, every parking lot wait, and every drive-through line across an entire summer, and you begin to understand the cumulative destruction. Independent automotive data supports this as well, showing that hybrid vehicles experience up to 9.3% more fuel consumption in city driving when running air conditioning at full load. City driving is where it hurts the most, because that is where the hybrid system relies most heavily on pure electric power. Every unnecessary watt consumed by the air conditioning compressor is a watt stolen from the electric motor that would otherwise move the car without burning a drop of gasoline. Honest mechanic truth, that full improvement only happens if your driving habits were already hurting the car. And leaving it on fresh air mode in July is the fastest way to hurt it. Toyota actually designed the hybrid climate control system to default to recirculation mode when the power button is turned on for this exact reason. On many Toyota hybrids, including the Camry, RAV4, Corolla, and Prius, the system automatically selects recirculated air as the starting mode when the outside temperature exceeds 75 degrees Fahrenheit. Toyota's own technical documentation states this is done specifically to reduce air conditioning power consumption and protect fuel economy. The engineers clearly understood the energy math, but millions of drivers override this default every single day without understanding what they are doing. Every press of that fresh air button undoes the precise engineering Toyota spent years perfecting. The damage from fresh air mode goes way beyond just burning more gasoline at a stoplight. Every additional charge-discharge cycle the hybrid battery experiences shortens its overall service life. Toyota hybrid batteries are designed to operate within a narrow, protected state of charge window, typically between 40% and 80%. When the air conditioning compressor draws excessive power, the battery drops toward that lower boundary faster, forcing the engine to kick in and push the charge back up. That is a full cycle. Over thousands of hours of driving in summer heat with the wrong air conditioning setting, those extra cycles accumulate rapidly. Battery degradation is cumulative and completely irreversible. A battery that cycles 3 times more often in summer is aging 3 times faster during those months. You won't feel it this year or even next year, but by the 7th or 8th year. Those extra cycles will be the exact difference between a battery that still holds strong and one that requires a $4,000 replacement. But that is only the beginning of how drivers accidentally sabotage their cars. There is one more setting built into your Toyota that does even more hidden damage when ignored, and a completely misunderstood mode that drivers disable because they think it's broken. While overriding your ventilation to fresh air mode forces your electric compressor to eat through your high-voltage battery life. The real tragedy is that millions of owners actively disable the exact automated features Toyota built to stop this bleeding. Let's look at what Toyota engineered into the dashboard that most drivers completely ignore. Many modern Toyota hybrid models include a specialized feature called S-Flow, which stands for Smart Flow Control. This system uses real-time occupancy detection through seat sensors to determine exactly which seats are occupied and directs air conditioning strictly to those active zones. If you are driving alone on your daily commute, S-Flow automatically reduces or completely shuts off airflow to the passenger seat and the entire rear cabin. This dramatically slashes the thermal load on the electric compressor, which means less power drawn from the traction battery, fewer engine start cycles, and immediate relief for your fuel economy numbers. Most drivers have no clue how much engineering went into this single button. Toyota actually filed for and received official EPA greenhouse gas credits for this exact technology, which tells you precisely how significant the energy savings are in a laboratory environment. The full S-Flow system earned a 3.3 grams per mile carbon dioxide credit from the EPA, which represents a massive reduction in real-world energy consumption when multiplied across millions of vehicles. Real-world owner data from RAV4 hybrid drivers proves that keeping S-Flow active combined with eco mode saves between 2 to 4 miles per gallon on standard trips in 90-degree heat. That is not a corporate marketing claim. That is real fuel saved by letting the car manage airflow intelligently instead of blasting ice-cold air into completely empty seats. Yet, a massive number of drivers disable S-Flow because they notice reduced airflow from the rear vents and assume something is broken. It is not broken. It is actively protecting your high-voltage traction battery from cooking itself. There is another layer to this climate control strategy that most drivers miss entirely, and it involves how you use your drive modes. Toyota's Eco Mode does far more than just soften your throttle response to prevent aggressive acceleration. It completely modifies how the high-voltage climate control system operates under load. When Eco Mode is active, the air conditioning electronic control unit automatically adjusts the target cabin temperature and caps the maximum compressor speed, regardless of what you set on the physical dial. If you get into a hot car and crank the thermostat down to 64 degrees Fahrenheit while Eco Mode is engaged, the system will maintain a much higher internal target floor to limit the initial compressor power draw from the battery. This brilliant behavior confuses owners who expect an immediate blast of freezing air, leading them to disable Eco Mode entirely. By turning it off, they remove the fuel-saving throttle mapping and the air conditioning power management simultaneously, forcing the compressor to run at maximum capacity. We need to understand the electrical reality of what is happening under the hood. The electric compressor in a Toyota hybrid operates on the full voltage of the traction battery, typically anywhere from 200 to 250 volts, depending on whether you are driving a Prius, a Camry, or a RAV4. It is a variable speed scroll unit, meaning the hybrid computer can spin it incredibly fast or remarkably slow depending on the exact cooling demand. The air conditioning computer calculates this target speed using inputs from the cabin temperature sensor, the outside temperature sensor, the solar radiation sensor mounted on the windshield, and the evaporator temperature sensor. This is an incredibly sophisticated system that works beautifully when the baseline inputs are reasonable. But when you override the ventilation setting to fresh air mode in extreme heat, you are feeding 100-degree air directly into that sensitive loop, forcing every single sensor to demand maximum compressor output. The compressor spins at its absolute limit, draws maximum current, and your expensive traction battery pays the price. Honest mechanic truth, these systems were never designed to operate as isolated buttons. Eco Mode, recirculation, and S-Flow form a unified, tripartite energy management strategy. Disabling even one of these features breaks the chain, spikes battery drain, and forces the gasoline engine to run constantly just to keep the voltage from bottoming out, fortunately. The first detailed fix to stop this relentless battery cycling takes less than 5 seconds and costs absolutely nothing. You do not need tools, you do not need to visit a dealership, and you do not need to buy aftermarket parts. You just need to re-establish the correct initialization routine every single time you step into the vehicle during the summer months. Step 1 of this protocol begins before you even touch the power button. When you approach your Toyota hybrid, after it has been sitting in direct sunlight, the internal cabin temperatures can easily reach 140 to 170 degrees Fahrenheit due to the greenhouse effect of the glass. If you turn the car on with the windows up and the AC blasting, the electric compressor instantly spikes to its maximum electrical draw to combat that superheated air trap. Instead, roll all 4 windows completely down for the first 30 to 60 seconds of driving. This simple physical act allows the ambient movement of air to purge the trapped superheated air out of the cabin naturally, dropping the internal starting temperature by up to 40 degrees in seconds. Step 2 is where you lock in the battery protection. Once that initial blast of superheated air escapes, roll the windows up completely and immediately verify that your climate control system is locked into recirculation mode. Do not leave it on automatic if the automatic mode keeps switching back to fresh air due to your local humidity levels. Force the system into recirculation manually by pressing the button until the indicator light stays completely solid. By doing this, you ensure the electric compressor is only processing air that has already passed through the cooling fins once, meaning each subsequent pass requires significantly less electrical current from the high-voltage battery pack. Step 3 requires adjusting your target temperature expectations to match the vehicle's physics. Stop setting the climate control to 60 or 64 degrees Fahrenheit in the middle of summer. The electric compressor will run indefinitely, trying to reach an impossible target in a hot cabin. Set the thermostat to a reasonable, highly efficient baseline between 72 and 74 degrees Fahrenheit, and ensure your Eco Mode button is depressed on the center console. In this sweet spot, the hybrid computer can rapidly bring the cabin to a comfortable temperature, allow the electric compressor to drop into a low power maintenance speed, and prevent the high voltage battery from dropping into the low state of charge zone that triggers the gasoline engine if you absolutely must have fresh air ventilation during long road trips to prevent the cabin from feeling stuffy. Use the timed interval method. Switch the system to outside air for exactly 2 minutes every 20 minutes of driving, then immediately lock it back into recirculation. This brief window provides more than enough oxygen exchange for the cabin occupants without allowing the evaporator core to heat up enough to trigger a massive, long-term power spike from the high-voltage battery pack. This simple daily routine, venting the superheated air first, locking in manual recirculation, maintaining a 73-degree baseline, and trusting S-Flow, cuts your air conditioning-related hybrid battery drain by 30% to 40% over an entire summer. You are actively reducing the thermal stress on the lithium-ion or nickel-metal hydride cells, saving fuel and extending the operational life of the most expensive component in the vehicle. But as critical as this ventilation fix is, it only addresses what happens while you are actively driving down the road. There is another catastrophic mistake that thousands of hybrid owners make while the car is completely stationary, a mistake involving the physical gear shifter that can drain a healthy traction battery to absolute zero in a matter of minutes while the air conditioning is running. Most drivers think they are being safe, but what happens next inside the hybrid transaxle changes everything. This brings us directly to the second critical hazard that can absolutely destroy your high-voltage traction battery in a matter of minutes while your air conditioning is blasting. It all happens because of a fundamental misunderstanding of how the physical gear shifter interacts with the hybrid transaxle when the vehicle is stationary. I see this exact scenario play out in the workshop all the time. An owner wants to sit in their car during a hot summer day, maybe waiting in a long drive-through line, at a railroad crossing, or during a roadside stop. Out of an old habit developed from driving traditional gasoline vehicles, they slide the gear shifter into neutral. They think they are relieving stress on the drivetrain. They think they are being safe. But on a Toyota hybrid, shifting into neutral while running the air conditioning is one of the most mechanically dangerous things you can possibly do to your high-voltage battery pack. Let's look at the hidden reality of how Toyota's power split device operates. When your vehicle is in park or drive, the hybrid electronic control unit is fully capable of managing the state of charge of the high-voltage battery. If you are sitting completely still with the air conditioning running, the electric scroll compressor eats away at the battery's energy. When the state of charge drops below its designated safety threshold, typically around 40%, the computer automatically fires up the gasoline engine. The engine spins motor generator 1, which instantly acts as a generator, pumping high-voltage electricity back into the traction battery until it reaches a safe level. This entire balancing act happens seamlessly in the background while you sit in air-conditioned comfort. The moment you slide that shifter into neutral, the hybrid computer completely disables the regenerative and charging logic. It is a built-in safety protocol designed to prevent the car from applying torque to the wheels under any circumstance while in neutral. Because of this absolute software lockout, motor generator 1 cannot act as a generator. The gasoline engine might still fire up and spin because the computer senses the vehicle is getting dangerously hot, but it is literally spinning freely in a void. It cannot send a single watt of electricity back to the battery pack. Meanwhile, Your high-voltage electric air conditioning compressor is still pulling massive current directly from the cells to keep the cabin cool. This creates a devastating downward spiral. The battery depletes steadily and rapidly. The state of charge drops past the 40% threshold, past the 35% critical mark, and plunges toward absolute zero. Because the vehicle is in neutral, the system is completely powerless to stop the drain. If you leave the car in neutral long enough, with the air conditioning running on a 95-degree day, the battery will drop into a deep discharge state. Once a hybrid battery drops below its absolute minimum voltage floor, the vehicle will throw a master warning light on the dashboard, disable the hybrid system entirely, and refuse to start. You cannot jump-start a deeply depleted high-voltage traction battery with jumper cables or a portable booster pack. The vehicle has to be towed to a specialized facility or a dealership where a high-voltage charging station must be manually hooked up to the pack, a mistake that costs hundreds of dollars in towing and diagnostic fees, not to mention the permanent, irreversible degradation caused to the internal cell chemistry. Honest mechanic truth. This mistake happens most frequently at automatic car washes, where attendants force you to shift into neutral, or when drivers idle on the shoulder of the road. If you are stationary in a Toyota hybrid, the shifter belongs in park, period. Never use neutral as a resting gear. The second detailed fix to protect your system involves a critical physical maintenance practice that 90% of Toyota hybrid owners completely neglect because it is entirely hidden from view. Your high-voltage traction battery pack generates a massive amount of heat when it cycles, especially during the summer when it is simultaneously fighting ambient temperatures and powering the electric air conditioning compressor. To keep those cells from cooking, Toyota engineers installed a dedicated cooling fan and ductwork system on almost every Toyota hybrid, including the Prius, Camry, and RAV4. The intake vent for this battery cooling system is located inside the passenger cabin, usually right on the side of the rear seat cushion or directly underneath the rear seat tracking. Every single piece of dust, pet hair, clothing lint, and debris floating around the floor of your car gets pulled directly into that intake vent by the cooling fan. Over time, this debris accumulates on the fan blades and clogs the incredibly tight cooling passages between the individual battery cells. When that fan gets clogged, the battery cannot shed heat. The internal cell temperatures spike. The hybrid computer restricts battery performance to prevent a thermal runaway, and the electric air conditioning compressor is forced to pull power from a severely compromised, overheating electrical source. This causes the battery to cycle even faster and accelerates chemical degradation by tenfold. To fix this, you must perform a routine inspection and cleaning of the hybrid battery cooling filter at least once a year before the summer heat hits. On newer Toyota models, there is a small, removable mesh filter located directly behind the plastic intake grill on the rear seat. You don't need any specialized tools to access it. You simply pop the plastic grill cover off using a flat trim tool or your fingers, slide the mesh filter out, and look at it. If it is coated in a gray layer of lint and dust, it is starving your hybrid battery of life-saving air. Wash the filter thoroughly with warm water, let it dry completely, vacuum out any visible dust from the ducting behind it using a crevice tool, and snap the assembly back into place. If you own an older Toyota hybrid that did not come equipped with a removable mesh filter from the factory, the dust has likely bypasses the grill and coated the fan blades directly. Cleaning this requires removing a few basic bolts to access the blower motor housing under or behind the rear seat. It is a simple 20-minute DIY job that saves you thousands of dollars down the road. Now, let's deliver the absolute honest mechanic truth about all of this, changing your ventilation habits, locking in recirculation mode, utilizing S-flow, and keeping your battery cooling vents spotless will absolutely prevent premature battery failure and stop your fuel economy from tanking this summer. But these steps will not magically repair a battery pack that has already been severely neglected and cycled to death over the last 10 years by a previous owner. These practices are designed to maintain and maximize the structural integrity of a functional system. If your traction battery cells are already chemically degraded and throwing internal resistance fault codes, A button on your dashboard isn't going to save you from a replacement. However, if your hybrid system is still healthy, taking control of these settings is the single most effective way to ensure your car crosses the 300,000-mile mark on its original factory equipment. Stop letting lazy driving habits dictate the lifespan of your vehicle's most expensive component. Go out to your vehicle right now, pop open the rear passenger door, and check that high-voltage battery intake vent for dust blocking the airflow. Clear out any debris. Commit to keeping the system locked in recirculation mode every single time the thermometer crosses 75 degrees. And let the precision engineering built into your Toyota work exactly the way it was designed to protect your wallet.